Hello everyone, in this video I will show you how we can use constraint in Unacademy Mechanica. Constraint will help users to get more control over an assembly. So we will find how we can use constraint in Unacademy Mechanica here. So before that I will use some title block. Maybe I can go with the ISO and paper size is 0. I'm okay with it. I'll click OK and then I will hit enter. So it will be inserted at 0, 0, and now I'm ready to draw some objects. So in this case I will take objects from the library. Maybe I can go for some ISO components here. Maybe I can take some bolt. So I will take some bolt from the ISO list. So maybe this one. So I will insert the bolt here, and maybe I can increase the rod length to 70, and that's fine. And again I need to take one more components. So we can take either one of this. Maybe we can take this one. So I will insert these objects side by side. So this is the objects, and in this case the thread diameter will be 20. So I am okay with it and I will escape to exit. Now before I proceed with the constraint, I would like to show you from the script master what are the parameters we had used to build these components. So these are the parameters. For instance, if we talk about the thread diameter, so we have parameters dr. If we talk about thread length, we have parameter b. So this way we have different parameters. So we will take these parameters to make relations between different components, right? So this way I can go to this objects as well to show you all variables, all the parameters we have here in this components, in this nut, right? So now to add some constraints, we should go to library and we should click on this small down arrow, and then we should click on add constraint, right? We'll click on that, and now we have two different options. Either we can go for parametric constraints or we can go for assembly constraints, but for now we will talk about the parametric constraint. And to do that we need to select the parent objects and the child objects. First I will choose the parent objects by clicking this arrow, and I will be able to choose the parent objects. The moment I clicked on the objects, and now it is listed in the parent objects. And now if I click this parameter box, now I can find all the variables that I just shown you on the library. Likewise, I will take the child object, so I'll click here and the child object's parameters will be listed here. So my intention is that to match the thread diameter for both the components. So I will double click on it and it will be shown here. And in the parent objects, I can say the diameter of the objects is this. So now I'm saying this parameter and this parameter should be in equal relations. I can set different constraints from these options. I can make it bidirectional constraints and many more things we can do here on this constraint. But for now, we are assuming that we need to make these two parameters equal whenever we use on an assembly. Parent objects will be the driver, and the child objects will be the follower of the parent objects. So the moment I will apply, so now you can see the diameter is equal. So this was 10 initially. If I double click on it, so this is 10, and now if I go to this, and it will be 10, right? So maximum available thread diameter for this ISO 4033 is 36. So now I am on child objects. If I try to change the thread diameter here on the child objects, I choose 36. I will apply, and I will now the preview is okay. The moment I will click OK, it will not change because this is child. So I will have to change the parent. This is important. So I'll double click on the parent objects and then I will change it to 36. So I'll say OK. Now it is changing to 36. If we go back to the parent objects and if we want to make it something 52, and it will not work. because the parent objects will work because it has the range. The ISO 4018 is it has the range of that thread diameter parameters. We have only available maximum available ISO 4033 is 36 thread diameter, so we cannot do that. But parent has independent liberty to change the size despite following the child. So now on this case I will go back to something in the range. Maybe I can go to something 27 and I will say okay. So the child and parent will be same in this case. So this is just a concept of how we can use constraint. This is a big chapter that you can use in Nanocad Mechanica to make more complex assemblies using the constraint. Thank you very much for your time. See you next time.